Hello everyone, I am Pasquale and I work here in EURECOM in the group of Rafael Tronsin. I mostly apply my research to digital humanities and, in particular, to video archives. This archives contains huge amount of material in which it is not easy to know which people appear in the video. This because the annotation made by archivists are not always present or not enough precise. On the other hand, in the web, plenty of pictures depicting politicians, artists, in general celebrities are present and easy to crawl. In my demo, I will show you a celebrity face recognition system which put together and leverage images coming from the web and face recognition algorithm. See you later.
In multiple applications such as web mining or news curation, we can get access to a big volume of text documents that we would like to automatically sort and further understand. One way to harness such resource is topic modeling, which consists of grouping unlabeled documents into coherent clusters based on common vocabulary and word distribution. We develop an API that unifies the interface for training and using multiple topic modeling algorithms, as well as simplifying their deployment for any particular use case or application. But how to know which topic modeling algorithm to use? We conducted a thorough evaluation of the different algorithms to compare their performance in multiple settings. Once we get our documents clustered, how can we automatically tell what the clusters are about? We leverage ConceptNet, a common sense knowledge graph that helps us find and identify central concepts that we can use to label the output of our system. So do you want to know how to turn your unlabeled documents into a coherent, properly classified collection? Come check our poster and let's discuss.
I'm presenting my topic of knowledge modeling and multilingual information extraction for understanding the Silk cultural heritage, which is connected to the EUH 2020 project Silk Now. The European Silk heritage is in danger. How can we help to preserve it? If you do not know much about this topic, then you actually understand what I want to say with this. Here in the middle you can see a handmade illustration of the knowledge graph we are building, and this is how the data ends up. It originally comes from many different sources in different formats that need to be unified, and domain experts need to interpret and map the semantic properties first. On top of it, we develop extraction and prediction tools to fill information gaps. We use AI methods like automatic information extraction, entity linking to enrich museum data and make this knowledge available again to both the public and companies who want to use it. We are working on semantic search tools, recommendation and questionnaire answering systems that make this knowledge easily explorable. Here you can see our interface, fueled by the knowledge graph we built. It makes it possible to browse through objects of various museums with all of them arranged according to semantic properties, like techniques or material. The Silk Now knowledge graph is also at the core of the virtual loop with which new silk textiles can be created virtually based on existing knowledge and even get printed or woven in real life afterwards. Thank you for your attention.
Hello, my name is Ji Xiong and I'm currently working at the Orange Labs. Our team's research focuses on the interpretation of the tabular data with knowledge graph. Tabular data is widely used in the industrial context, so it is one of the major types of data sources for the knowledge graph enrichment. For the first step, we aim to annotate information from tables. For this purpose, we have three targets: mapping between a cell of the table and an entity of the knowledge graph, define an ontological type of the table column, and identify relationship between two columns. We have successfully achieved this goal by using graph embedding technique and studying their similarities. So, are you interested in how we did?
Hello everybody, my name is Embeddings and today I will present you a project I've been working on, which is Next Trip Recommender. Don't you ever dream seeing a nice picture on your Instagram newsfeed and immediately feeling that you would like to go on holidays on a place like this? With our AI-based recommender system, it is possible to have this. It is possible to have your next destination based on the image and also many other information like the place you have visited in the past. On top of our recommender system, we have developed a user interface where one can enter his flight information he wants to travel in addition to the image he liked, and we will propose, thanks to our recommender system, your next destinations. If you want to have more information about this, please come to the poster session.
So you use Twitter, but how? What type of user are you? Are you the type who uses it for work, regularly reposting your employer and colleagues? Are you the one who follows the trending political hashtags and comments, engaging in debates? Or are you the one who wants a break from it all and likes soap cutting videos? That's what we're able to tell using 200 million tweets provided by the RecSys challenge, using the content of the tweets and the user past interactions. Among others, solving this task means being able to handle this huge amount of data, modeling tweets that can be written in more than 30 different languages. So if you want to find out how we use technologies such as multilingual BERT word embeddings, knowledge graphs, sentiment and cognition analysis to predict your behavior on Twitter, have a look to our poster.
Good morning, everyone. I'm Graziano, and this is my third year of PhD CFO fellowship with EURECOM and SAP Labs France. Most of my research focuses on machine learning interpretability, and today I'm going to talk about a specific branch of interpretable models, rule-based models. In this case, interpretability comes from the structure of the model itself, that consists of if-then-else rules. The goal is to find a set of rules that is small and compact, meaning a few number of short rules without sacrificing predictive performance. If you want to know more, I invite you all to join the virtual poster session, and you can also scan the QR code on the slide to have a look at the paper. Thanks a lot.
Hi everybody, my name is Jonas Wacker. I'm a PhD student in the Data Science Department supervised by Maurizio Filipponi. And I will present our paper that we recently published to ICASP 2020 in a collaboration with the École Normale Supérieure and the startup based in Paris called Lightron. The paper is called Kernel Computations from Large-Scale Random Features Obtained by Optical Processing Units. So what an optical processing unit is and what kind of features it computes for kernel methods in machine learning, you will find out in my poster presentation. See you then.
The title of this work is Model Monitoring and Dynamic Model Selection in Travel Time Series Forecasting. Machine learning provides accurate models for price time series forecasting. However, the development and deployment of such models represents only the first steps of the system's life cycle. Instead, it is the monitoring and maintenance of the models which carry most of the cost and difficulties in time. And this is mostly due to the time-evolving complex patterns and non-stationarities of the time series, which make forecasting models deteriorate over time. In this work, we propose a data-driven framework to estimate the forecasting error through a supervised learning approach. The predicted performance measure represents a surrogate of the model's future performance, and this allows to perform model monitoring by detecting accuracy deterioration over time, and also to carry out model selection by comparing the performance of different models dynamically.
The automatic supervision of IT systems is the current challenge at Orange. Given the size and complexity reached by its IT operations, the number of sensors needed to obtain measurements over time, used to infer normal and abnormal behaviors, has increased dramatically, making traditional expert-based supervision methods slow or prone to errors. In this paper, we propose a fast and stable method called unsupervised anomaly detector for multivariate time series, based on adversarially trained autoencoder. Its autoencoder architecture makes it capable of learning in an unsupervised way. The use of adversarial training and its architecture allows it to isolate anomalies while providing fast training. We study the properties of our method through experiments on 5 public datasets, USAD, demonstrating its robustness, training speed, and high anomaly detection performance. Through a feasibility study, using Orange's internal data, we have been able to validate Orange's requirements on scalability, stability, robustness, training speed, and high performance. This work has been accepted for presentation at KDD 2020.
Good morning, everyone. I am Riccardo Capuzzo. This is a brief introduction of EMDI, which is the project I've been working on for the past year and a half. EMDI stands for Embeddings for Data Integration. With data integration, I mean a set of tasks that are done to combine data coming from different sources, shown here as an example as text of rectangles. In the end, we would like to have a super table that combines all the original data in one single source. This is EMDI's workflow. We start from some relational table that contains some kind of information, like movies in this case. We use them to build a graph like the one in the picture, and then we convert the graph into embeddings. Embeddings are used to represent information using points in space. This allows to measure distances between them and to do operations with that. We exploit this property to perform data integration. Once we have the embeddings, we can use them for various tasks, such as the visualization that you can see here or at my demonstration. Thank you very much for your attention.
Hello, my name is Mohammed, and I'm going to introduce today our system, Corona Check. So as COVID-19 struck, several false news about the pandemic has surged and has put the lives of many in danger. The World Health Organization has even named this as an infodemic and has put fighting this infodemic as a second point on its response to COVID-19. At EURECOM, we have built a system called Corona Check, which verifies statistical claims about coronavirus. So given an input statement, we apply state-of-the-art AI algorithms in order to transform the statement into an SQL query so that we can verify the statement and say if it's true or false with an explanation included. So here is a quick preview of the system. We input a sentence and we click on check, and the system will tell us if the statement is false or not. We can get an explanation by just clicking. Please join me later in order to know more.